All right, so our next session is on keeping it simple towards ZTA and service mesh. It's going to be by Dre and Jack from Bright Machines, and it is sponsored by Intruder. Intruder is a powerful vulnerability scanner that makes securing your cloud infrastructure a breeze, and you could try it free at intruder.io. Over to you, Bright Machines.
So hi, welcome to our talk, Kiss Towards ZTA and Service Mesh, with essentially doing defense in depth with layer of envoy for authentication and authorization sidecar. So we had planned to come there to present in person, and well, unfortunately things happened. So congrats if you made it. Thank you for attending everywhere you're attending. Let's do intros. So hi, I'm Jacques, the guy who left the live stream on. Besides that, I'm in the product security and compliance team. And Dre?
And I'm Dre. I'm on the platform engineering team.
And together we work at Bright Machines. And here's an officially sanctioned description of who we are as a company. So let's go over it together. So headquartered in San Francisco, Bright Machines is an innovative technology company that is pioneering a new approach to intelligent software-defined manufacturing. It leverages computer vision, machine learning, 3D simulation, and robotics to fundamentally change the flexibility, scalability, and economics of production. With more than 550 employees worldwide, Bright Machines operates R&D centers in the US and Israel, with additional fields operation in North America, Central America, Southeast Asia, and EMEA. Bright Machines is reimagining how products can be designed and produced to address the realities of today and the future ahead. Rethink everything you ever knew about manufacturing. Visit us on the web. So with that covered, let's get to the talk. So essentially the context of our work is, all right, how much can you do in how little time, given that we're a startup? So what we're presenting is what we did over about 2 quarters with mostly Dre and me. And the grading criteria, if you will, was how simple will this be to explain to new hires, because we're a startup, we're growing. How reliable will it be to operate, because we don't have the full SRE team to throw at it. And how extensible is it for our future? So in order to get there, we applied religiously the 2 main principles that we know will get us out of trouble. KISS, essentially like keep it simple, stupid. And because not being humble will not pay on the long run. And ZTA as an architectural principle. And so there's a bunch of books and blogs. We like the book that we showed here. We really like the writings from Google on Beyond Corp and Beyond Prod, and especially the part about make sure it takes more than 2 failures before you're exposed. We try to apply that, hence the layers. So the rest of this talk is gonna kind of like move inside our stack from the outside. And we're gonna use the same diagram as kind of like breadcrumbs to guide you through the slides. So first we're gonna discuss our login, then how the perimeter and the authentication sidecar both use envoy. And the part about what surrounds the service, that point I hand it over to Dre to present that part. So the login. Well, first apply KISS on it, just don't own it. Like there's a reason there's service providers there. It's really hard actually to do well. Like putting a login box on the internet is first step, but after that you have to make sure infrastructure is always up, because if it isn't, your customers can't get in. Make sure you got spam and abuse, make sure you protect against DDoS. Each of these were like full-size teams in previous companies I've worked in. So we decided not to own that. Furthermore, you're subjected to credential stuffing or slow password cracking. It'd be good to have protections for that. That's hard to build too. And then you end up owning a lot of PII, actually, if you own an endpoint like this. So it's nice when you don't own all that. If you externalize that service, you can go down to essentially being a data controller from a GDPR perspective. And we do like that, given that we operate worldwide. And also, if you use a mature provider, then you just do SSO on your system, and it just works. From other providers, you can chain them. So that's nice too. So that covered then we build the perimeter. So the perimeter is using envoy in its like edge configuration. And maybe bonus points if you recognize where that from which movie this picture comes. Here's what it looks like. So we're on AWS. We use, so if you want to quickly follow the path is 1, 2, 3, 4, we put little aids, like reading aids in there. We use Route 53 to alias into our external NLB, where we use AWS ACM to host a certificate that is generated there so that we can't even like lose the private key. And that's an added warranty for us, that it limits accidents. Behind that, there's a layer of envoy that's running on Fargate. We chose Fargate so that we don't have to own the base image. And that's one less thing to worry about. And essentially what happens is the requests come up from our single page application, hit the layer of envoy, which then that's JWKS polling against our IDP to verify whether the JWTs are valid or not. If they are, then they get to come inside our infrastructure, further inside, to hit another layer of load balancers that perform internal TLS termination. So we re-upgrade to TLS on the back, and then that's it. So the properties we get with this is that we own very little. We have no base image, no custom container, no configuration distribution. So the part that was missing in that explanation is that actually we just use AWS parameter store, and we just gzip and base64 encode the envoy config. So at the end, we just have really like Terraform and an envoy config. By the way, that config, we get it into envoy with, it's not pictured in there, but like a little, again, plain vanilla bash sidecar, init sidecar that just takes that data and just mounts it for envoy to run. So let me hand it over to Dre for what happens around the services.
So we want to continue with the zero trust architecture. And to do that, we like to use Envoy everywhere. So Jacques went around how we use Envoy at the perimeter to validate the JWTs coming in against our identity provider. And we basically do that again in front of each service. This is just a little more detail about how we do that. Essentially, the JWTs are checked through Envoy by validating the signature against the public JWKS that our auth provider stores for the public to look at. And yeah, we do that at every service at the perimeter. And a benefit that we can utilize that the auth provider gives us is that they allow us to specify a payload in the JWT for us to use in the authorization workflow, which we'll get into more in a little bit. But essentially, we can just encode any type of claims or entitlements that we just have to ensure that our authorization sidecar can understand. And then, we want to keep the services simple. We want them to focus on application and business logic. So authentication is owned by the authent sidecar. Authorization is owned by the auth sidecar. And really, the service is only responsible for relaying the claims from the authent sidecar to the authorization sidecar. And in addition to that, we would hope that our services are able to make the correct requests to the authorization sidecar. And that's really it. Those are the kind of guarantees we hope that the services follow for this whole workflow to happen. They don't have to worry too much about the securities behind the whole auth flow.
Yeah, the assumption there is like if the service can't make the right resource, it's probably like incorrect for other like deeper reasons. And
a little extra nugget of zero trust architecture we have in there is that we strip the signature from the claims at the Envoy sidecar. So essentially, when the JWT is checked, we send through only the header and the payload and strip the signature so we don't have live credentials floating around in the service.
Yeah, and this way, your service that's in ultra debug logging mode cannot leak credentials in the logs. So not active credentials.
Yeah. So our role definitions are static. So we've elected to use a static system. Essentially, what we've done is we've made a multi-level map that we store as TypeScript code that runs in the authorization sidecar. And all it is just a 3-level key dictionary where you index by the service, by the resource and the operation. And at the very end, you have a list of roles that are allowed to act upon that service resource operation combo. And what the authorization sidecar does is when that query is made, it goes to that value and then checks the JWT of the user who called the service and ensures that they have at least one of the roles in that values list. And if they do, the authorization sidecar will send an access granted request, and the service can vend data as needed or do the operation as needed. And if it's denied, the service is responsible for sending back a 403 to the user. And we lovingly call this a TypeScript database because that's really what it is. It's just a little key value lookup that we have running on each sidecar. And we elected to keep it that simple because the sidecar just allows us to keep everything static and localized to each service.
Yeah, it's more precisely, we call it the static TypeScript database, and that guided us a long way. As you can see, the next slide.
So the keyword here is static. We don't really have anything too dynamic going on here. So there's really no need for a centralized service to do all the fancy management you need. And by using sidecars, we miss out on a lot of fun stuff that comes from having a centralized auth service. For instance, we would have to we'd have to configure throttling on the calling services to avoid brownouts. And because we have the possibility of brownouts, if we have a centralized auth service, we could take a really big outage since all of the auth traffic goes into one place. By having these sidecars, we can compartmentalize failures, not just from the sidecar failing or the service not working as expected, but when we want to patch the sidecars, we can do those patches one by one and not have to analyze all the traffic in our cluster when we have an update go out. And another really cool benefit of this that helped us just kind of get the integration going with the limited time we had is that we had an always yes sidecar that developers can use while the permissions were being deliberated on for their service, since that's not necessarily an easy process. In fact, Jacques can speak to some of the multidisciplinary.
This part, it was just like getting everyone together was really rough. I mean, for the right reasons. It's like you got to get UX to agree on the use cases. You got to get security to agree on what's really allowable for that role. You get the backend to folks to also implement the right things in terms of their APIs and agree on the APIs. And then you got product management was like, oh, and here's that new feature that we would like also. So to keep all that going, you gotta provide the backend engineers something they can integrate against and test against to lower like the barrier of entry. And so by having that sidecar that just always says yes, there's no excuse not to integrate. And that's one thing that really enabled us to unblock a lot of integrations. And then once they made the right queries, and once we agree on what the access metric should look like, then we can give them the right sidecar. That's been really nice.
And an added benefit of this is that we have metrics to see what the integration is throughout our system. So it's kind of gives us a little trust but verify system to ensure that everything's going as planned.
Okay, and so real quick, we're gonna eat a little bit in the Q&A time based on the careful call at the beginning. This lets us essentially very easily go ahead, Ray.
Yeah, if you want custom roles, just make sure the naming is consistent and add that role name everywhere you need in these in the TypeScript database that we have. Essentially, all you need to make sure is that your JWTs always have the consistent naming.
Yeah. And so that's our golden path to accessing our resources. And in quick recap, in the end, we've built a perimeter with strong authentication and defense in depth. And one of the big things with adding all those waypoints is that every one of those is a place where we can build more mediation and where we can perform more anomaly detection. And using standard identity provider, we can do SSO to multiple apps if we need to, and we can do SSO inbound, and we've tested that from other identity providers. The other part of the parting thoughts is, for KISS, we essentially have services that are not even responsible anymore for authentication and authorization. They're just responsible for making the right query and relaying the right reply. We can't remove a component at this point and keep the system running. It's really as simple as it can be, or dumb enough that it just works, however you want to look at it. And for ZTA, yeah, there's so much less trust in the system right now because we make a lot more explicit trust decisions at more explicit decision points. And despite all that, we managed to actually do some cool stuff like WebSocket end-to-end, where we essentially upgrade the WebSocket credentials. You can't do an authorization header with WebSocket inside a browser. So the token gets shoved hard into, like, stuff into the sub-protocol header, and that gets upgraded to a real authorization header at the perimeter. And then it flows through the normal authorization flows. And we're able to do that because we got Envoy as a Swiss knife to normalize traffic at the edge. We're working on OAuth for Carp apps and custom roles. And for service mesh, we'll have to just pick a control plane. So if you've ever seen like the equivalent of Unix wars, but for who's got a good control plane, like there's one there. But we're well positioned because we already have Envoy at strategic places. So thank you for attending our talk. We'll happily take questions, and we're also on the Slack. You can find us, Jacques Thomas Dre Mahaarachchi. We're there.
Thank you, everyone.
So thank you. We do have a couple of questions. The first is, how do you operationalize and run Envoy at scale? And have you evaluated any alternatives?
Is there streaming delay for the questions? Or was it super clear?
Can you hear me?
I see some questions in the Slack. We'll get to at least one of them. Question from Joel Thompson. Do you run into problems with mapping very large numbers of service role and action tuples and trying to reason about them and audit them? Well, actually, the way we do this is because it's checked into code. We have developers send PRs when they want to update their services to have new resources or new operations. So this at least pulls in a point of deliberation when we want to update the access control matrix with new permissions.
Well, it sounds like there's questions maybe coming over Zoom.
Yeah, can you guys hear me?
Yep.
Okay, there we go. So one of the first questions we had was, how do you operationalize and run Envoy at scale? And have you evaluated Istio as an alternative?
Right. So two things. Istio is built on Envoy. So from that perspective, you need Envoy no matter what. Right now, we're being very modest, like based on what we know from talking, for instance, with the Lyft folks who originated Istio, Envoy, is that, back there, their control plane is very simple, at least used to be for quite a long time, and it was also checked in. So in this case, we got configurations that we can push, and we can restart our fleet. I don't know if our scale is what you mean by at scale. Like, our scale is not necessarily gigantic, but we gotta have strong security. So I hope I'm helping. Essentially, we use AWS SSM to push the configs, and we restart the pods if we need to switch the config. It's really, really minimal, and that's orchestrated by Terraform and the deployment parameters of Fargate for that. Actually, ECS on Fargate for that service.
And when we run Envoy next to each of the services, we run them as Kubernetes deployments alongside the services as a pod, essentially a pod of 3 different containers.
Yeah. And in terms of Istio, it's just the amount of base boilerplate that you commit to the moment you say Istio is honestly a little bit terrifying. And it seems, at this point at least, it's scary to us. It also seems that the whole multi-cluster is not fully solved. And, if you look at our first slide, you see those machines, they're in a factory. We have a hybrid cloud environment, and so it's not clear how we do that with Istio at this point. And it looks like we're at time. So thank you for your question. We'll happily continue on Slack.
Yeah, thank you, everyone.
Thank you.